Okay, guys, last video on chapter 21. So this isn't really in your textbook, I don't think, anyways, but I definitely thought it was worth taking a quick look at. So now we're going to be talking about experiments, so a significance test with an experiment. So when making an inference about your difference in proportions, using data produced from random sampling, the parameters are the two proportions of successes in the corresponding populations. Defining the parameters in an experimental setting is more challenging. Most experiments on people use recruited volunteers as subjects. Subjects are not randomly selected, so we cannot generalize the results of an experiment to some larger populations of interest. We can draw cause and effect conclusions that apply to people like those who took part in an experiment, but because these are volunteers, we actually don't have to check the 10% condition when performing inference about an experiment. So the 10% condition is independent. If they're people running doing an experiment, they are independent of each other. What happens to the results of one person is not going to change the experiment at all for another person. So individuals, they're all going to be independent, so you don't have to check that condition there. That's the significant difference there. That is mostly that you don't have to check the same conditions. So let's take a quick look at an example with a significance test in an experiment. So you'll see it's a little bit different, but not much. High levels of cholesterol in the blood are associated with higher risk of heart attacks. Will using a drug to lower blood cholesterol reduce heart attacks? The Helsinki heart study recruited middle-aged men with high cholesterol but no history of other serious medical problems to investigate this question. The volunteer subjects were assigned at random to one of two treatments. 2,051 men took the drug gemfibrozil to reduce their cholesterol levels, and the control group of 2,030 men took a placebo. During the next 5 years, 56 men in the drug group and 84 men in the placebo group had heart attacks. Is the apparent benefit of the drug statistically significant? Perform an appropriate test to find out. So here's our two hypotheses. We're going to say that my null hypothesis is that the difference is 0. This time my alternative hypothesis, we're going to want to say that we think the difference between them is less than 0. The other way to have written that is that the proportion 1, which is the drug, is going to be less than the proportion 2, which is the placebo. So we're trying to see if the drug improved heart attack risk. So less heart attacks than the placebo group. So something else to consider is they didn't specify a significance level. I'm going to use 0.01 to reduce the risk of making a type 1 error here. Okay, so a type 1 error would be rejecting, saying that they are the same, so there is no difference between them. So I think that a type 1 error would be more significant in this case because you would be talking about people suffering a heart attack, which I think is kind of more of a serious risk than a type 2 error in this case. So if I want to reduce the probability of making a type 1 error, I'm going to use a lower significance level. So I'll use 0.01 rather than 0.05, which is our conservative. So in order for us to perform our significance test, as always, we have to check our condition. So it's random, but you're going to see that it's not from a random survey. It's not an SRS. It's a randomized experiment. So you'll have to see that that wording um, in the problem. So whether it's a randomized experiment or the volunteers and then the treatments were randomly assigned. So you'll see that will sound a little bit different, but it still needs to be randomized. Large counts is exactly the same, so you're still looking for them. So the number of successes, which yes, in this case would be heart attacks, even though they're not successes. It's kind of like that flu question that we had in class. So 56 successes and 1,995 fails with the drug, 84 successes and 1,946 with the placebo. All are at least 10, so normal condition is met. Independent. So this is the one that we could kind of get away with. So due to the random assignment, these two groups of men can be viewed as independent. Individual observations in each group should also be independent. Knowing whether one subject has a heart attack gives no information about whether another subject does. We don't check 10% for this. So if the conditions are all satisfied, we can perform our significance test at our 0.01 significance level. So I'm going to first start with getting that pooled proportion. So I'm going to add together my successes, put it over the combined sample sizes. Here's my test statistic. I get a Z of, notice again, your parameter, we're saying there's no difference there, so we're assuming that they're the same, so the parameter is still 0. And I will get a test statistic of negative 2.47. So now I'm going to rely on norm CDF to help me find my p-value. I will get a p-value of 0.068. So because 0.068 is less than my significance level, we'll say that the results are statistically significant. Therefore, we will reject our null and conclude that there is convincing evidence of lower heart attack rate for middle-aged men like those who take the drug rather than those who take only a placebo. And that's it for Chapter 21.